All right, so today we're going to talk about amateur radio and electric vehicles. I noticed this presentation was presented as mitigating interference, but truth be told, there is some of that. There is just not a lot of it to deal with. But I'm still going to talk about the topic with regards to my installation and some others that I've actually seen and people sent to me and such like that. So well, we're going to talk about several considerations in a EV for amateur radio and two-way radio in general. And there is some bonus content that's not in the deck that I'll try to share later on. Spoiler alert, amateur radio operators are not the only ones who are using EVs to run radios. That seems interesting, doesn't it? All right, so like I said, RFI is only one part of the equation. And it isn't really a big problem in modern EVs. I mean, people, there's this myth on the internet that says that every time a Tesla rolls by, that HF just goes to pot. Well, I hate to disappoint people. That used to be the case, and in a lot of cases with the Toyota hybrids in particular, there used to be a lot of interference from them. And as time went on, everybody kind of realized that, wait a minute, that interference was kind of like, electromagnetic compatibility is not just a passing thought. It's not something that could be trivialized. And that later on, well, maybe RF interference is a two-way street. And I'll tell you a little bit about some of my experiences with Tesla service with regard to an RFI issue that really wasn't an RFI issue until I connected the dots. My previous gas car, actually, one of my previous gas cars was a Honda Accord, and that thing actually was pretty terrible with RFI. It was a 2004 Honda Accord. It was the first car I bought in the US after owning a Honda Civic in my old country. And but it was an adventure. So anyway, there are a few things you need to be aware of, and we're gonna, talk through it. This is not going to be excessively long presentation, but I'm hoping to get some time for discussion. And yeah, LED lights do affect HTs and radios and such like that. And most of that has to do with switch and power supplies. Okay. So our topics discussed. So we're going to talk about where you put the radios and antennas in an EV and where not to put them. We're going to talk about power because power is a big deal in an EV. Yes, we're going to talk about RFI. We're also going to talk about integration with existing systems because when a lot of manufacturers have redesigned EVs and they released EVs, what they've done is they've totally reimagined the automobile. And there have been some kind of controversy about that. So not just Tesla, but other vehicles are getting rid of like the traditional set of buttons and knobs that you have to control a vehicle, and instead you have this touchscreen. And Tesla goes all the way. They eliminate the little binnacle, the little dashboard cluster that they even had in their older cars, like the Model S, which I had one of, and they replace it with a center LCD screen. And, that's controversial for some people. They think that, well, without buttons, you're going to be a lot more distracted on the roads, which could be true. It does, I think it does, could facilitate some driver distraction. On the other hand, I think there are benefits in terms of it could provide flexibility. It could also provide some ability to change and add features. So like, for example, today's vehicles are what I like to call software-defined vehicles, where you have a set of hardware that you get, and then you get additional features added on by software. So like, for example, when I originally got my car, and I had a full self-driving package, which shouldn't be called that, but it's it's an enhanced driver assistance, it should be called. So the full self-driving package essentially allows the car to steer itself, supervised on city streets and highways alike. The problem is the problem is that it didn't have that and didn't have all those controls, yet it added that on later. Even some things in the hardware, like the headlights are what you call adaptive headlights, and they were not approved in the US. So you had them approved in Europe. So in Europe, essentially, the adaptive headlights are where the car's camera sees an object in the road, like the car coming toward you, and it will dim the headlights just for that object. So you could have your brights, and then that object will be dimmed. This way, you can have good lighting, yet you're not blinding other drivers, which I think, I see some of these pickup trucks, especially with these unfocused LED light bars that are just blinding the living daylights out of people, pun intended. Let's see. Dave says, designed for Six Sigma states that if a system produces noise, it's wasting energy, and this must be improved to eliminate that waste. That's a good point because Ted Rappaport and 9NB actually designed something called a waste factor. If you look at, he had a really nice presentation that he gave to the ITU recently, and he talked about his the waste factor, which is something he came up with. So he's actually a researcher at NYU School of Engineering in their wireless research facility. I was going to talk about the future as well too. So the future, you're seeing a lot of new vehicles on the road. A lot of vehicles are becoming electric or electrified, which basically means they're hybrids. But you have different definitions of hybrid. You have Volvo with the mild hybrid, which essentially is a motor that gives assist to a traditional gas engine car. And then you have the full hybrids. And then you have plug-in hybrids, which have a little bigger battery than a traditional hybrid. And you also have the ability to plug it into the wall, and you get a certain amount of electric range. Anyway. All right. So yeah. So with that, we'll talk about what's an EV. So an EV is a car powered by electricity. Not surprisingly, most of them are powered by batteries today. Some are actually powered by internal combustion engines, what we call hybrids, like I mentioned. Some are powered by fuel cells, which are hydrogen. Disclaimer, I'm not going to talk about fuel cell EVs because I had no access to any of them. And I'm a little hesitant to even install a radio in a hydrogen fuel cell vehicle because, I don't know. I just think it'll be a Hindenburg style disaster. But just so you know, those are on the roads as well, and those actually will probably have some of the same interference noise profile as a battery electric, maybe some additional because of fuel cell. But like I said, this presentation will focus primarily on battery powered cars, right? That you plug in and charge from there. All right, so what this is not, okay? And I have to say this. This is not the green agenda. This is not the liberal agenda. This is not the woke agenda. This is not convincing you that EVs are better. This is not banning gas vehicles. This is not saying EVs are better. I'm not interested in the debate. I think, if you have interest, great. If you don't have interest, great. We can disagree. You could see that this guy is fully interested in the green agenda. As you see, what he's holding is something green. Okay. Anyway, all right. So my history with EVs, I've always been curious about them. I joked as a kid growing up that I would own an electric car as my first car. Well, it didn't work out that way. It ended up being my fourth car. So I ended up getting 3 gas cars, and eventually I got an EV. So my first EV was a Tesla Model S, and the the thing that really kind of spurred me on is that, well, I figured it was it would have nice performance, one, but two, I kind of like the idea of plugging it in. And in New Jersey we have full serve gasoline where you're not allowed to pump your own gas, so it's kind of inconvenient to do that. So, but you could plug in your own EV. Unfortunately, I want to call it a crash because what happened was I was on a way to a ham club meeting in Long Island, and I ended up bottoming out in there. They were repairing the roads, and they had like a big you know, a sink in the road. I don't know if they like scraped it up or something. But all I knew is that my car, basically, I heard a loud noise, and then the car felt really weird, and I got off the road, um, drove into a gas station of all places, and then so like the tire was like 45 degrees. Okay, so that was a problem. But I replaced it with a 2022 Model Y Performance, which has been kind of nice actually. Uh, and it's been like a nice platform for radios. And I haven't put all the radios I want to put in it yet. And there might be some changes, but I'll show you what I have in there and how I've dealt with some of the issues. It's different from a lot of other vehicles in many ways, and I had to learn some stuff. For example, it doesn't have a 12-volt battery, which could pose a problem. I also reserved a Cybertruck, and I actually got an email to configure it. I don't think I want to spend $100,000 on a foundation model, so I'll wait. So, okay. I reserved on day one, by the way, when Franz von Holzhausen took a metal ball and shattered the windows. Okay. So this is my first car, and you can see my son standing next to it. This was after his first communion. He said, "I want to take a picture of your car." I'm like, okay. So it was freshly washed and waxed and stuff, and he took a picture with it. Red was a nice color. It's one of the more modern EVs, so like the first vehicles were, when I say modern EVs, the first vehicles were EVs. And I want to say, like, it was a challenge with them. They had like some issues with charging. And I want to bring up a picture here for you. I didn't put this in the deck, but I want to show you. Let's see here. So they used to actually charge those with a mercury vapor rectifier. And GE, I think, used to actually, GE was the one who used to make them. I'll bring that up some other time. I'll show you that after that. Now, one of the interesting things about radio, this had FM radio, it had AM, it had XM radio, Sirius XM. It wasn't so great with electromagnetic compatibility because a lot of the cables and a lot of the cables, yeah, the slides are visible. Okay. Yeah, so a lot of cables weren't really shielded. And this was like when they started manufacturing, they manufacture a lot of things by hand. But especially when you're doing regenerative braking on these cars, so the way an EV works is that you drive forward, you press the accelerator, and then it takes power from the battery and it applies a variable frequency drive to the wheels. So the motors are AC motors in this case. And of course, the higher the frequency, the more power you get to the wheels. The problem is that to slow down, they actually put it in reverse. So the wheels become alternators, and they push back that energy in the battery. This helps them become very energy efficient. And as a side effect, it also would reduce the wear on the brake pads. Okay. So actually, it was not common for Tesla vehicles or other EVs to not require brake replacement until like 100,000 miles, which is crazy when you think about it. Whereas with a gas car, my Honda Accord, I actually replaced the brakes first time. I bought it brand new in 2003. It was 2004 model. I replaced the rear brakes at 18,000 miles, which is, I found that to be quite shocking that it wear out at 18,000 miles. But anyway, so during the regenerative braking process, you find that procedure actually produced a lot of noise on the AM band. And this is where they began to get a reputation for not having good electromagnetic compatibility. So the thing about Tesla vehicles is that in the past, they used induction motors, which were actually designed by none other than Nikola Tesla. So Nikola Tesla, designed the induction motor, and those are used. But eventually, with the Model 3, Tesla switched to a different type of motor. They switched to what people are calling permanent magnet motors, but they're actually really switch reluctance motors. So it's close. They do use permanent magnets, but they're a different technology. And I think that's part of the reason they have less of a problem with EMC. And Dave is saying how he uses engine braking on his diesels. Yeah, so it is similar to the concept of engine braking. You're not using friction to absorb the energy, but what you're doing is you're capturing the energy back. And in the case of a diesel or like a truck with Jake brakes, you're actually converting it to mechanical energy, or sorry, sound energy, and waking up the neighbors. But in the case of an EV, it converts to electricity and sends it back to the battery. This was my old car. This was a Honda Accord 2004. It lived quite a life. It almost got to 300,000 miles. And I sold it. I didn't get much of anything for it, but that car was beat to hell. I mean, literally. But I had a lot of good memories in that car. And I had radios in it too, which I took out. Well, this is what I drive now. So this is a 2022 Tesla Model Y. Like I said, I got this in 2022 to replace my Model S, which suffered the unfortunate incident in Long Island, New York, on the Long Island Expressway. So you can see it is a performance model because you have the red stripe below the dual motor badge. That's how you identify them. And you can see I have an antenna on them. All right, let's talk about problems and solutions here. So these are problems you have when you're dealing with electric vehicle. The antenna location. Because as you notice, this car, and I'll show you this. Let's see here. Anyway, so if you notice in the previous photo, most of this top of this car is glass. And you're going to have a hard time drilling glass. And even if you drill glass, you're not going to mount an antenna on top there. So that is one of the problems. The other problem is, where do you mount your radios? Well, it's not as simple as it seems. In my old cars, I was pretty, um, I really didn't care. I just drilled a hole in the floor and then mounted the radios below the seat, and I was happy. I can't do that in the EV. If you drill the floor, you're in for a rude awakening. Power, not as straightforward. I'll explain why. Even though the cars have a low voltage system, it's not like you think it is. And of course, RF interference. So RFI is a concern to be concerned about, and we'll talk a little bit about too. Mounting the antenna. I put this picture for hilarity in case anybody knows what it is. VHF and UHF is really simple to install an antenna. You can't drill on an EV, right? The roof is glass. Now, there are Teslas that are actually being modified for police use. And what they do is, so there are a couple companies that are doing it. One is called Unplug Performance. And there's another company that makes a car called Model PD, which essentially is a Model Y or Model 3, but they modify it for police use. So what they do is they take off the glass roof and they put like a carbon fiber thing on top, and you could put antennas and light bars and stuff like that. Anyway, so no drilling. The roof is glass, the body's aluminum, and you really don't want to drill to put an antenna. HF might be a little more complicated, and I'll explain what that is. So by the way, this car is a Honda Civic, and that's not an antenna. That's a parking pole. So in Japan, a lot of the cars have parking poles for the driver to kind of see where the curb is so they don't hit the curb. All right, so I did a clip-on mount, as you can see here. I did the Diamond K400, which is a popular clip-on mount. And you put that on the left side here, and there's like a little space between there. Thank you, Tesla, for leaving panel gaps. Okay, that's a joke. But there's a clip-on space you could do there, and I screwed it down just enough so it kind of like, gets in there and doesn't do too much damage, but at the same time, it's still firmly in there. But this kind of mount has been in my cars that I've had radios in, except my first Honda Civic. So the first Honda Civic actually had a Motorola technician drill a hole on the top of the roof and use that. But anyway, so the clip mount here, that's one thing. And it works, and it's fine. It's totally fine. I'll show you close up. So this is a close up here. You can see here. Um, I might be mistaken about this being the K400, come to think of it, but it is this mount with is a clip mount, and it has this thing here to hold a PL259. And as you can see here, because of low garages, I basically have to tilt the antenna down, and that keeps the car in the garage at night. I don't have HF yet, unfortunately, but what I'm thinking of doing is actually putting the antenna on a trailer hitch, because this car has a trailer hitch. I don't want to have HF full time in it because, to be quite honest, I park in places a lot of times that have low, roof clearance, right? So I don't want to have to get out my car and take down antennas all the time. When I used to work at my previous job, our parking garage used to have, like, it was low. It was like only 7 feet. So you could barely get a lifted pickup truck in there. Any vehicle with antennas, I'm sure Andrea is going to be off limits in there, her and her Rover. But my car really, I had to, when I was going into the office, I put the short antenna on. I'm hesitant to use a trunk clip. There is somebody who's using a trunk clip, and I'll link that YouTube video, and he has a HF. But yeah, so he had that, and he has an ICOM 7100, but he didn't go like where I went with the power stuff. Like I said, this won't be permanent, just temporary. I have used my ICOM 705 for portable operation with it too. So what do I have in it now? So I have a VGC VR N7500, and I have Android tablet for control. I have the trunk lip mount, and I have the Comet SBB7, which is a nice long dual band antenna, which is really nice. It gets me out to all the repeaters. I'm on APRS. If you look for N2RJ-9, I'm on APRS pretty much everywhere I go. And so you can spy on me. And then you can also send me messages too. And, it works out well for me. And the VGC VR N7500 is not a digital radio. It's FM, but it has APRS. So this is one of the early iterations that I had of the VGC in here. And I had a tablet. And this tablet was I think it was like $40 at Walmart at the time. So this is one of the basic Android tablets. I ended up removing it and getting rid of it, and getting a Lenovo 8-inch, because the reason is that this was too small to drive safely with. And, even though I really shouldn't be manipulating the controls when I'm driving, I felt that this was a bridge too far. Now, the other thing about this tablet is that the screen felt kind of cheap. So, well, what I did was my son ended up taking it, and I ended up getting the Lenovo. So, and he used that. He has another tablet, a big Samsung tablet, but he uses this for different things. All right, so here we get into some real meaty stuff, right? Power supply. So EVs are generally powered by a 300 to 800 volt battery, and you more find most vehicles now have a battery in the range of like 400 volts. So most Tesla vehicles have a 400 volt battery. I think the Cybertruck has like 750 volts or something. I know Porsche uses 800 volts with the Taycan, and there are others, who do that. But using that for accessories is kind of not good, because I'll give you a little secret. All these manufacturers actually don't make all of their own equipment inside their cars. Like for example, the um the power window switches in Tesla vehicles were actually made by Mercedes, believe it or not. And now I believe they make their own or they use another one. The infotainment systems were made by a company called Sin, which actually is a subsidiary of Harman now, right? And if you know Harman, Harman actually makes audio for a lot of different cars. And Harman, I think, is a Korean company. You might know them from like Harman Kardon audio speakers. So you need a smaller battery, right? And it's used for entertainment, used for airbags, which are important, used for the things like the horn, the lights, and a lot of other stuff, power windows, locks, um, pretty much everything in your car, door latches and stuff like that. But I'll talk about the voltages in a second here. So the older EVs, including Teslas, had a standard 12-volt lead acid battery. And oh yeah, so you see, Harman is a Korean company. They're owned by Samsung. Thanks for that, Carlos. So yeah, so the older EVs, including Teslas, had a standard 12-volt lead acid battery. And this was good because you could essentially connect anything to that you wanted and get a high current. And the DC to DC converter from the main traction battery would power everything you want. The newer ones, though, and the Model 3 and the Model Y and also the Tesla Plaid, like the new Model S and X, they have a 16-volt battery. And that battery is more like a buffer. It's not like a regular car battery, which has like a huge reserve capacity. This one is a smaller battery designed to basically just float, and then they have a DC to DC converter that will periodically recharge this. And it's the same principle I used for the radio system. Now, the pros and cons of this are that the 16-volt lithium-ion battery, it lasts longer. So the previous 12-volt lead-acid battery would actually wear out within like 2 to 3 years. And it was not common, like midway through your warranty, you're replacing a 12-volt battery. And this one actually, though, has a slightly higher voltage. It won't work with some accessories. So one of these accessories is actually an air pump that Tesla used to sell that you could use to pump air in your tires, but it doesn't work with it anymore. It's too high. The Cybertruck is even different. So the Cybertruck pioneered a 48-volt low voltage electrical system. The reason they did that was to save money on wire. So they have wire adds weight, right? You have all these wires in a vehicle, it adds weight. And yeah, you see. So Dave said how the auto wiring harness suppliers will try to get OEMs to go 48 volts. So yeah, Tesla started to do that with the Cybertruck. I don't think they've done that with any of the other vehicles yet. But for compatibility, they still have 12-volt limited, including the cigarette lighter output. Now, interestingly, the Cybertruck also has an inverter in the back, in the bed, and Ford Lightning actually has that too. And if you're interested in Ford Lightning, Josh, KI6NAZ, on his YouTube channel, he has videos of him in his Ford Lightning because he bought a Ford Lightning. He says he doesn't like Elon, which is why he bought a Ford. So he got that and he runs high power out of his Tesla. I'm not his Tesla, out of his Ford Lightning in the back. So, but anyway, the point is that you have a proxy to 12-volt, right? So my solution to this was I added an additional auxiliary battery. So I got a Bioenno lithium iron phosphate battery, and I got a solar MPPT charge controller to draw power from the circuit with the auxiliary port. And then I ended up powering the radio from the battery. So this I actually learned because I actually do some consulting for a company called EcoFlow, and EcoFlow actually makes these portable power stations that kind of had the same principle. You could plug in a solar panel and then charge the battery, but you could also simultaneously use power from the battery while it's charging from solar. So the advantages of this are that you're drawing only 3 amps from the Tesla electrical system. So that's negligible. And the thing is, even if you want, you can actually make this to where it plugs into the cigarette lighter outlet. And, technically you're not voiding warranty or anything. So, they can't say how you put some accessory that damages the system. It solves the voltage issue because the MPPT controller now it charges and regulates the battery, right? It regulates the voltage of the battery, and it does not it does not like overcharge the battery. So the MPPT controller will stop charging the battery when the battery's full. Whereas if you just connect it to the 12-volt line, that thing will be charging all the time, and you don't want to overcharge a lithium iron phosphate battery or any other battery. If you turn off the vehicle, you can leave it transmitting APRS or even crossband repeater if your radio supports it when a vehicle's off. Um, that's an advantage. So in terms of RFI, so it's less of a path for conducted RFI. So a lot of people think that, in order to get voltage from the car, to get power from the car, you want to connect it directly to the DC to DC converter. But I've noticed in some of the wiring harnesses that they actually have like some ferrites and stuff on the wiring harness for EMC compatibility. And bypassing all of that is going to have some problems in terms of the the overall interference profile. So less of a path of conducted RFI is a big one. If you choosing an MPPT controller, I got one at a Hamfest, and the seller assured me that yeah, it's good enough for ham use, so I trusted him. But you can actually get one from DIY Solar for You. I have a couple of them I'm testing. I bought from him, and he's a ham, and he makes them specifically RFI friendly. And the other advantage of this is that you can actually use an additional power like a solar panel if you wanted to, without draining your car battery. So this is my setup here. You can see how I have the entire thing. So in the back of the vehicle, there's actually a I want to call it like a tray, but this is like where so in the Model Y, you can get it with 7 seats. This would be where the 2 back seats would be. And in this, what all you have to do is go in the rear cargo area, lift up the back board, and then you have this. Now, don't be fooled. I did not drill this, because if you drill the floor, you'll find that you'll probably drill into the battery, which you don't want to do. So let me see if I could annotate some of this. If not, oh well. But anyway, oh, sorry. Yeah. So on the left side, you see I have the solar controller. It's like a no-name brand, but it's actually shockingly good with RFI. You have the VGC radio in the middle. I use a rig runner power distribution here. And then I have the Bioenno battery on the side. And I basically just use Velcro to secure all them down. And it hasn't moved. I've had this in the car for about a year, and it really hasn't moved or done anything. And here you could see me trying to, yeah. Oops, sorry. Yeah. You could see me here in the procedure trying to get, yeah, yeah, yeah. I have music playing when I do this. So, see? Okay. All right. So Dan asked, what do I do about grounding the car radio? So not in this picture, is that I do have a ground that's connected to the body. Um, I don't know if I have a picture of it here, but yes, I did add a ground and I basically bonded everything later on. The rest of the vehicle actually is pretty well bonded, so I didn't put any additional ground straps or anything, but there are points on the vehicle where you can add a ground wire. And I use basically the same as I would do in any vehicle. I use copper braid and I just connected that to a bolt on the vehicle. Okay. And this here is interesting because I was able to, get APRS messages here from the from somebody on my YouTube channel right on a tablet here. All right. See? Yeah, that's a good question. The 12-volt side is actually grounded. So the high voltage side is, I'm not sure if the high voltage side does, but I know the 12-volt is negative ground. Okay. So here is a car here in a different situation here. It's outside. And I have another picture of something else here. All right. So in terms of RFI lessons, so there really wasn't that much to begin with. I've actually done some testing on AM radio, and I have a full video on that on my YouTube channel that I'll show you, where I actually drove around with the AM radio. I suspect, though, that some of the problems with AM radio is conductor interference, and in taking apart the vehicle and looking at some of the electrical system, some of them actually have like ferrite cables. In the newer cars, in the older cars, it was terrible because they essentially it was messy. Whereas in these newer cars, they streamline a lot of things. Um, so there are a few things that you can do to actually keep the RFI down. One of them is to keep the cables short and far away from vehicle electronics. The other one is that you ground everything and you bond everything. And the other one is that you there was a retrofit that Tesla actually did to my vehicle that to add ferrites to the airbag cables, because I had one issue of an airbag light that kept coming on. So typically you'd see here, and I took this from a technical presentation about things here, that modern EVs tend to have a lot of RFI mitigation already built in. For example, they have common mode chokes connecting to the motor. They have shielded cables already. And, so there isn't really a lot that could be done. Yeah. So that's true. Yes. So what I will clarify is that, and I think I have it in the next slide here. So the interference to the vehicle, I had one case of interference. And yes, that might have been something after the fact. I had an issue with the occupant positioning, OPDS, occupant position detection system. Essentially, it's so it's something to deal with safety for the all right. So in a traditional vehicle, typically you don't want to put kids in car seats on the front seat, right? So you put them in the back seats, which is fine. But people still put their car seats on the front seat sometimes. So essentially, the federal regulations are that anything over 40 pounds is um, you know, is an adult, I believe, and anything under 40 pounds is a child. So within a few pounds to like 40 pounds is a child. So what they do is they attempt to detect a child with weight, and there's a weight sensor in the front seat. And how that works is that it goes to the airbag computer, and then the airbag computer now will determine whether to turn the airbags off, because if you have a child in a car seat, you don't want to have airbags flying in their face because that'll injure them. An adult could, will not will feel they'll feel some pain, but they won't feel, it won't be as catastrophic as to an infant. So I had a problem with the OPDS. And then Tesla actually had a TSB. They replaced the cable with one that had a choke built in. So there are really no problems at all with this now. But I used to have crazy problems with randomly going off airbag lights. And this used to drive me crazy until I decided, you know what, I'll take it into the service center and see what they would do. So that's one case. But generally I transmit 50 watts on the VHF and UHF. I don't have any problems to infotainment or anything. I don't detect any, like click or noise in the infotainment system. It's very clean. And, there's nothing interference wise to the vehicle. Charging. So charging interference is a concern. I've noticed, especially at Electrify America, the Tesla superchargers are actually pretty good with interference. So you go up to a Tesla supercharger, and it really doesn't give that much interference. The problem is like this Electrify America charger, which I don't use now because they're so expensive, but this Electrify America charger would wipe out everything when I put it to charge. I don't know why, because they still have the cabinet away from the quote unquote dispenser, but they're just terrible. So I can't operate radio when I'm fast charging the vehicle, which might be a problem, but in a gas car, you're not operating radio when you're at a gas pump either for safety reasons. So I don't know. I think it's equal to a gas vehicle in that regard. But this is something to bear in mind. Home charging. So my Tesla Model S actually had problems with home charging. So with home charging, I would plug in and I'd get like a low level hash on the lower bands in particular. And while the vehicle was charging. So my solution to that was I actually set the charging, and I did this for other reasons too. I set the charging to start at midnight and end at like 6 a.m. The reason for that is twofold. One of them is essentially when I'm not on the radio, I don't want to be charging, right? And getting hash on the radio. Even though it was a low level hash, I do a lot of weak signal work. But the other thing was that you want to charge when it's off peak anyway, not because I have off peak rates, but because the cooperative kind of encourages people to do heavy loads, especially during the summer after midnight, which is when the electricity usage tends to taper down. But anyway, the Tesla superchargers have moderate noise. Electrify America is really terrible, but you're only there temporarily. So for those of you that don't know, there could be, this is my theory for it. My theory is essentially that the superchargers have these DC fast chargers have their cabinet outside, their charging hardware outside, and they have more of them. And they're running on three-phase, and it's essentially you're delivering anywhere from 50 to 350,000 watts to the vehicle, right? It's a massive amount of power. Compare this to home charging. So the charging hardware, like the actual battery chargers on the outside of the vehicle. When you're home charging, it's a little different. So AC goes in. So this is where this fast charging is where DC goes into the charge port directly. The home charging, actually AC goes into the charge port. And then it connects to an onboard charger. So this onboard charger is inside the vehicle. And I think when they design this vehicle for electromagnetic compatibility, because they do actually have extensive EMC testing, they actually shield it a little better than some of these public chargers. So an electric vehicle charger, a level 2 charger, essentially is just a smart switch that when you plug in the vehicle, it will switch on the power supply, and then it will draw only as much current as it needs. Yeah, so Barry says is how he had an individual in the condo call the police claiming the car was causing RFI. Um, and then, yeah, okay. Yeah, people love to blame things. Yeah, especially so-called electrosensitive people. So the future, what am I doing in the future? So I might replace the VGC radio with whatever Kenwood brings out and some custom software. I'm actually working on something where I can use this with an Android tablet. I'm not crazy about the VGC radio because I'll tell you why. APRS kind of works and sometimes it doesn't work. It essentially, I think it places the APRS stack inside the tablet software. The hmm the problem with that is that sometimes the tablet doesn't get the location, and then you might see me stuck at a location in APRS while I'm actually somewhere else. So this is a problem. HF radio, I have something in testing, so I'm not going to reveal it just yet. I wish I had it in time for this presentation, but I'm actually testing something. I'm going to have something on my YouTube channel, so watch out for it. The trailer hitch mount for the antenna. So that's where I'm going next in terms of like the HF antenna for this Model Y. And that I think is going to be the most feasible solution because I don't see myself putting an HF antenna anywhere else on this vehicle to bend, panels and stuff like that. And of course, the Cybertruck. Whenever they start regular production, I think I'll order mine. I'll complete my order. All right, and with that, it wasn't too long, but thank you for watching. All right, and I'll pass it back to Dan.
Well, I got to unmute everybody or everything. Here I am. Hi, thank you, Ria. That was a great presentation. Please send your slides to me when we're done here. Anybody got any questions out there? Hands up, hands up. Okay, I think we pretty well covered everything in chat. You were pretty good to go in. I hear Barry's voice.
Yeah, Ria has covered everything in chat.
Okay, Barry, thank you. Well, Ria, thank you again for coming on. That was a great presentation. Good timing.
Yeah, well, thank you, Dan. I really, appreciate coming on. I think you guys do a great job. So,
Okay, your whoever turned the overhead lights on behind you did not do you any favors.
That's just
you know
her
what?
normal stove.
Yeah, I replaced. So the bulbs were replaced, and then I used to have two of them unscrewed, and then now it's just totally things. So I just unscrewed them again.
It's when your head's in the way of the light, it looks great. When you move your head where the light takes over, the camera gets upset.
Yeah, it's just terrible. I'll need to, fix that somehow.
All right. Well, again, I appreciate it. Let's do a little scan here. Anybody got any questions, comments?
Also, and you want me to email you the presentation, Dan, or
And if it's pretty good size, I'll send you a link for a large transfer.
do you want it in PDF or do you want it in like
I would prefer PDF. If you send something else, I'll convert it.
Okay, no, I'll do that. Yeah, I'll send in PDF because I didn't do it I did it in Keynote, which is a Mac thing. So
Okay. Okay,
yeah.
well, again, I appreciate it very much. Oh, Dan's got his hand up. Look at that. Hi, Dan. Go for
it. Yeah. Hi, Dan. Hi, Ria. Sorry I got in late. Does Tesla publish any information specifically about radio installation, presumably for public service? But I imagine there'd also be stuff useful for HF. And hopefully you'll be real free with what you do if and when you change to a Cybertruck. Seems like that would be a hard one not to want to do HF from.
Yeah. So I haven't seen any documentation, so Tesla's kind of tight on the documentation. Um, a lot of these shops that actually did radio. So there's one called Unplugged Performance, right? And I'll show you this one. There's one called Model PD. I'll show you these guys. So Tesla's very tight on this. They don't. I wouldn't expect anything from them. The only thing that's forcing their hand now is right to repair. But some shops have done customization for law enforcement, and I don't believe that. You know. So let's see here. Yeah. So this is what they've done inside, right? You can see they have the console and
Beer can holders.
yeah, right. Ohio. Okay. And you see here they got the push bars, and then so you could probably glean some things from them, but I have not seen anything official from Tesla.
Okay,
They
and
have
the same week that I put a deposit on the Cybertruck,
mm,
I think I shared with you and everybody else who I thought would be interested. The Tesla provided EMS stuff you want to know if one gets in an accident, and there was a pretty good description of much of the electrical components where
yes.
they were and how to deal with them, not to electrocute yourself.
So that one they do have a whole section for first responders,
Okay.
right? And so they tell you where all the power cables are, and they also have labels on the vehicle where not to cut, and then they also have a loop on the front you could pull out to disable the battery, right? The high voltage. So yes, so you see like they have the emergency response guide. Let me see the Model Y here. The emergency response guide, they show you here a bunch of different things. So I guess you could probably use this. I know the Tesla clubs actually do this training for fire departments. So you see.
Yeah, I imagine an all steel vehicle would be a pretty nice ground plane.
Yeah, so yeah, the Cybertruck's stainless steel. I actually saw one at Dayton Convention though. Somebody had one. I think one of the either who was it? Might have been HRO or DX Engineering, one of the people had one there.
So a DC to DC converter to knock it down to 13.6 plus or minus 15%
Mm-hmm.
Of a 48-volt DC system it might
So
go a long way.
yeah, so I don't think that you'll have necessarily direct access to the 48-volt system in the Cybertruck. I think what's going to happen is they have a 12-volt converter for 12-volt accessories. All right. So
Okay,
I,
Carl,
I
raise your hand.
Good seeing you. Congratulations on the new gig.
oh, thank you.
Carlos, go ahead. You're muted.
Hey,
Carl.
hi, Ria. Thank you for the presentation. Excellent presentation. In the same line as Dan's question, are there any advice, or is there any advice from Tesla regarding the grounding points for accessories? Because I know for sure that in the case of Ford,
Yeah.
F-150s having a lot of aluminum parts, they warn against hooking up accessories or grounding accessories randomly throughout the chassis, because it will cause the similar metal reaction that will cause corrosion and void the warranty. So they urge every Ford F-150 owner to consult the dealer before attempting installation of equipment, like for example, ham radio equipment. Is that the case with the Tesla vehicles?
Yeah. So there is actually so as I mentioned, Tesla actually gets a 12-volt supply via DC to DC converter, and that is located below I believe it's on the right side of the rear seat from what I remember. And there you have positive and negative terminals. You can actually connect directly to the negative terminal there to get your ground.
Great. Okay.
Yeah.
So as long as you keep the ground at that point, no problem
Mhm.
with the warranty on the car.
Right, no problem, and the thing about car warranties is you have federal law protecting you anyway, called the Magnuson-Moss Warranty Act. And how that works is that they have to prove that your modification caused the damage.
Yes. And what about the antenna? Because you are also grounding the radio through the coaxial, because the antenna is attached to a metal part of the vehicle, which is bonded to other metal parts. So it's actually ground. Probably not as good as the other ground on the
Right.
DC-DC converter, but it is ground.
Yeah, so it is, I mean, the thing about it is that I didn't pay too much attention to that ground. Maybe I should pay more attention to it but I found that, when I did the SWR checks and stuff like that, it was fine. So, maybe one day I'll go and address that. I'll probably run like a ground strap to that down to some other point.
Or maybe it's a good idea to wrap a couple of turns of the coaxial to a ferrite core or something like
Yeah.
that.
So
Just as a preventive measure, right?
So I actually have the coax coiled up,
Okay.
kind of like, yeah. I have because that one was actually because I got a long coax, but I actually coil it up. So that probably has some effect to break any common mode as well too.
Great. Thank you, Ria.
All right, no problem.
Okay, Dave's got something in the chat there.
Oh, they were
Yeah,
talking, we're talking about making, Carlos was pointing out that you get a ground connection through the coax as well. And that's one of the reasons why you don't put a fuse in the negative supply cable, because that fuse could go out and you wouldn't even know it. And instead,
Right.
all of the current then would be running through the coax, the shield, which is a bad idea.
Yeah, true.
Okay,
That's a good point.
all right. Anybody else got any comments or suggestions or whatever out there? I hear nothing. Ree, it's been great seeing you again. It's always a pleasure. Thank you for doing the presentation tonight.
Well, Dan, I appreciate it. And thank you for being a willing audience.
All righty. Well, we'll get this wrapped up for the night. Say 73s, everybody. And for those that
Thank you,
want,
Ria.
we'll see you tomorrow.
Good night, all. Thank you, Ria.
All right, bye.